Good morning to all. Okay, students. Now we are studying about some important compounds of sodium. Last class we have discussed some compounds like common salt, caustic soda, bleaching powder, then baking soda and baking powder. Today we have been discussing the next compound, namely sodium carbonate. Sodium carbonate. As I have told you earlier, when we are studying a compound, there are three names. Its common name is soda ash or washing soda. Its common name is soda ash or washing soda. Its chemical name is sodium carbonate. Chemical formula is Na2CO3. Correct? Na2CO3, 10H2O. First, how we can prepare sodium carbonate? It is prepared by heating sodium bicarbonate. By heating sodium bicarbonate or hydrogen carbonate. That is 2NaHCO3 gives Na2CO3 plus H2O plus CO2. Sodium carbonate is prepared by heating sodium bicarbonate. When heating, we get Na2CO3 sodium carbonate. On recrystallization, Na2CO3 plus 10H2O gives Na2CO3 10H2O. Here you can see 10H2O. It is known as van der crystallization. You can study the next topic. It is known as van der crystallization. It is a part of the molecule. With the presence of 10H2O, this is not wet. It is dry itself. It is a part of the molecules. So we have to discuss about sodium carbonate. How the molecular formula of sodium carbonate is Na2CO3 10H2O. Sodium carbonate is Na2CO3. And same it is correct molecular formula. That is, when it is used for washing purpose, washing soda or soda ash, its chemical name is Na2CO3 10H2O. How it is prepared? By studying the properties of sodium bicarbonate or sodium hydrogen carbonate, we have seen that on heating sodium hydrogen carbonate on heating, it decomposes to give sodium carbonate H2O and CO2. On recrystallization of sodium carbonate with 10H2O, Na2CO3 10H2O is formed. It is washing soda or soda ash. So in examination, there may be a chance to ask, write the chemical name of soda ash or washing soda or the chemical molecule formula. Then you write Na2CO3 10H2O. Then what are the uses? It is soda ash or washing soda. You will know that it is used as a cleaning agent for cleaning dresses, dishwasher, or it is used as a main use is cleaning agent. Second use is it is used for reducing the hardness of water. You in lower classes you studied that water. There are two types of water. soft water and hard water. The normal water we get from the well is soft water. At the same time, if calcium bicarbonate or slight amount of calcium sulfate it is dissolved in it, it is called hard water. It's called hard water. What is the reason for the hardness of water? Or how hard water is formed? Hard water is formed by dissolving calcium bicarbonate. Calcium carbonate is insoluble, but a slight amount of calcium carbonate may dissolve in water. Calcium bicarbonate or calcium sulfate, when they are dissolved, they are called hard water. How we can identify or distinguish a hard water? The soap does not form FOAM. Soap padayatilla. Soap padayatha vellathinaanu hard water. Hard water. Soap padayatha. It is not suitable for washing or drinking. For washing purpose, this hardness of water can be removed by adding sodium carbonate. So, what are the main uses of sodium carbonate? One, it is used for cleaning. It is used as a cleaning agent. Second, it is used for the removing hardness of water. Third, it is used in the manufacture of glass, industries, glass, paper, etc. It's also used. The next topic we are going to is water of crystallization. Water of crystallization. It is the fixed number of water molecules present in one molecule formula of a salt. Fixed number of water molecules. Fixed number of water molecules present in one formula of a salt, one molecular formula of a salt. It is a fixed number of water molecules present in one molecular formula unit, one formula unit of a salt. For example, copper sulfate is ordinarily right. The molecular formula is copper sulfate. That means this copper sulfate is CSO4, but the actual correct molecular formula of copper sulfate is CuSO4 5H2O. In every copper sulfate molecule is attached with 5 water molecules. These 5 water molecules is known as water of crystallization. One copper sulfate molecules contain 5H2. We all know that. What is the color of copper sulfate? Blue. Same day it has a crystalline shape. This water crystallization gives it a crystalline shape and at the same time blue color. For example, if we take some copper sulfate in a test tube and heat, some copper sulfate is taken inside the test tube and heat. What happened? This copper sulfate H2, this 5H2 will escape and it turned white. The color changes to white and the crystalline shape loses and it becomes powdery. You know that in board mixture, they have used copper sulfate and calcium hydroxide. That copper sulfate, when we purchase from the shop, it has a crystalline shape, not powder. And same with calcium hydroxide is powder. When we take 2-3 pieces of copper sulfate in this tube and heat, after heating some time, two things happened. One, the copper sulfate loses its blue color. Second, the copper sulfate is changed to white powder. When it loses its blue color, it changes to white. Enzyme changes the powdery taste. Then arise another question. What is it? If we add a 2 drops of water what happens? It regains its blue color. Similarly, the molecular formula of sodium carbonate is Na2CO3 10H2. Their 10H2 is known as the water of crystallization. Then you come to the derivation, the fixed number of water molecules present in one molecular formula and one formula unit of a salt. Sodium carbonate, Na2CO3, 10H2. Here 10H2 is known as water of crystallization. It is chemically attached. It is a separate. It is not a separate form. It is chemically bonded to the water molecules. But on heating, water molecule itself escapes to the atmosphere. Similarly, there is another compound, namely gypsum. CaSO4 2H2. CaSO4 2H2. It is known as gypsum. Here the water crystallization is 2H2. The fixed number of water molecules. So here also the common name or this is industrial name or commercial name is gypsum. Chemically it is calcium sulfate. 2H2. On heating, it loses 1.5 H2O. Then it becomes CaSO4 half H2O. This is known as plaster of Paris. Plaster of Paris. First you note the difference between gypsum and plaster of Paris. Gypsum, both are chemically calcium sulfate. Gypsum and plaster of Paris are chemically calcium sulfate. Then where lies the difference? The difference lies the number of water molecules of water crystallization. In gypsum, CaSO4 2H2, 2 water molecules. But in plaster of Paris, there is half H2. There arises a question about there is any stability in the case of half H2O. We can divide a water molecule into half. Now there is not a problem. Two CaSO4 molecules share a full H2O. Then when they divide, they get half. They never divide. Two plaster of Paris molecules. Each molecule have a half H2O. When two molecules join together and to form share a one molecule, then when we are writing the formula, CaSO4 half H2O. They are not exist in such a way. They exist two CaSO4 molecules share one molecule. Then there is not the possibility of dividing a half H2O into half H2O. Do you understand? One molecule contains half H2O. They never exist in the form one molecule. Two calcium sulfate molecules share one molecule. Their water molecule is always the for understanding purpose we write half H2O. But actually it is situated Actually, it is situated how two CaSO4 molecules share one H2O. That is not, when we write it, half H2O, it is wrong. We always write half H2O. We know the use of plaster of Paris. The term plaster, we are very familiar. When we injured a bone, any finger in our hand or leg, when we suddenly go to the hospital and the doctor plastering the fractured part. The material used for fracturing bones is plaster of Paris. There is the name plastering. It is used for plastering. It is used for plastering. When your friends or anybody absent for the class any day, you don't want to happen to your hand. It is there. It is like plaster. That means his or her bone fractured when he fell on the ground. Fractured. Then it is used for plastering fractured bones. This may use it. It is also used for making toys, etc. So here we have to learn three things. One, what do you mean by water of crystallization? What do you mean by water of crystallization? What do you mean by water of crystallization? Water of crystallization means the fixed number of water molecules present in one molecular formula of one formula unit of a salt. Fixed number of water molecules present in one formula unit of a salt. Here you stress the word one formula unit. One formula unit of a calcium is two formula unit of it is never written as 4H2O. It is never written as 4H2O. Each calcium will be 2H2O. Similarly, copper sulfate CuSO4 5H2O. Similarly, there the water crystallization is 5H2O. Similarly, sodium carbonate Na2CO3 10H2O. Where 10H2O is water of, known as the water of crystallization. That is the fixed number of water molecules present in one formula unit of a solid. Here we can see four examples. One, sodium Na2CO3 10H2O. Second, copper sulfate CuSO4 5H2O. Third, calcium sulfate CaSO4 2H2O. Fourth, plaster of Paris CaSO4 H2O. Here CaSO4 H2O is known as plaster of Paris. Why it is called plaster of Paris? You heard about the country Paris. That is the answer also. The plaster of Paris was discovered and mined in a huge amount near the rocks near Paris. Hence, it is known as plaster of Paris. It is a white powder. Then, how it is used for? Why it is used for plastering bones? I said to that it is used for plastering bones. CaSO4 half H2O. This is plaster of Paris. CaSO4. It is used for plastering fractured bones. Why? Because on mixing with water, we purchase it from white powder. When mixing with water, what happened? It changes to gypsum, and it sets very quickly. Very quickly it sets to a hard substance, and at the same time it expanded slightly, minute. So if a fracture is happened to your left hand with gypsum block, the hospital doctor from the hospital, they immediately bring plaster of Paris mixed with the water, and then they paste around the fractured part. And then within seconds, what happens? It sets into a hard substance. It sets into a hard substance. And at the same time, it's expanded slightly. Not very tight to our skin. These two qualities, based on these two qualities, what are two qualities? Sets quickly and at the same time expanded slightly. Set quickly, it sets quickly and at the same time expanded slightly. So there is air circulation between the blast and the skin. Otherwise, there will be decay take place without the presence of air. So this is it is used for plastering. So this chapter is over. You may go through each lesson, each line, each page, each topic, each word. In this sentence, in this lesson, there will be importance given to each word. You have to become clear about everything given in the textbook. There is nothing to avoid it. There is no selection. This is important and this is unimportant. All the topics discussed in this chapter are very important. So you have to first today take 3 papers, then a brief notes. On paper you have to written a brief notes on us. What do you know about us? May written it. Second, another paper you write, and below you may write the properties of acid. First you may write all the things related to acids are written. I will give you a photocopy of some important foods and the contents. You may not learn them by heart, but when you see the foods, mango, guava, and such tamarind, you remember that these things shows this food shows this particular quality due to the presence of a particular acid. Then you may automatically learn the things behind it. Then the second thing is to measure the strength of an acid. First of all, you when you hear the term acid, the thing came to your mind is acid. It is due to H positive hydrogen ions. Hydrogen is equal to hydronium ion. Hydrogen ion, the strength of an acid means hydrogen ion. A substance, if it becomes acids, all the substances, not all substances containing hydrogen are not acids. If it becomes an acid, what happened? In presence of water or moisture, it produces hydrogen ion. So whenever you hear the term acid, the thing came to your mind is what? In presence of moisture, it produces hydrogen ion or hydronium ion. The strength of an acid. First is what is an acid? How is the strength of an acid? We all know that some acids are corrosive. At the same time, some acids are not corrosive. It depends upon the number of hydrogen ions produced. This process is known as what? Dissociation. Acids, in presence of water, it dissociates into hydrogen ions. If it does not undergo dissociation, hydrogen ion does not produce and it not shows the properties of an acid. Then the other thing is how we can measure the strength of an acid using pH scale. pH scale. In the notes, it is clearly explained. You may please note that pH of thing is 7 is what is a mediator in the pH scale or divider 7, the number 7. Left side acids and the right side bases. I said to you that the pH 7 neutral. That is mediator. Above 7 there are above 7 there are bases. That means on increasing 8, 9, 10 basicity or the strength of bases increase. But in the case of acids, on left 6, 5, 4, 2, the number decreases, the strength of acid increases. The pH value 1, it is the strongest acid. pH value 2, the strength decreases, 3 again decreases, 4 again decreases, 5 decreases, 6 decreases, 6.5 nearly reached neutral, 6.9 nearly reached the neutral, almost neutral, 7 it becomes neutral. That I will show you below the periodic table in your note, below the pH scale. Below the pH scale in your notes I given to you, there is clearly said that pH is equal to 7 means H positive ion is equal to H OH negative ion. That is no. pH below 7, H positive concentration H positive ion is 8 and H positive OH negative ion is less, it is acid. pH above 7, OH ions increases, concentration increases and it is base. Now let us see some questions given in your textbook. The questions at page 33. What is the common name of the compound Ca or Cl2? What is the common name of the compound Ca or Cl2? Bleaching powder. Name the substance which on treatment with chlorine yields bleaching powder. The production of bleaching powder, we have learned that it is produced by the action of chlorine over trislakered lime. Slakered lime. Here there is also so many names to it. Lime, cuclane, that are calcium oxide. Lime and cuclane are calcium oxide. That's also I given in your the end of the notebook, at the end of the notes of this chapter, a table where they are written as the common name, chemical name and molecular name. At the same time, slakered lime is known as calcium hydroxide. The second answer is calcium hydroxide. Name the sodium compound which is used for softening the hard water. Sodium carbonate. Because in that hardness of water is due to in which calcium sulfate is dissolved in. Calcium carbonate or calcium sulfate is dissolved in water, it will become hard water. This hardness of water can be removed by adding sodium carbonate to it. So then it will become soft water. So the substance used for softening the water is sodium carbonate. Next, what will happen if a solution of sodium hydrogen carbonate is heated? Give the equation of the reaction. This is the today we learned how we can produce sodium carbonate Na2CO2 by heating sodium hydrogen carbonate. 2NaHCO3 gives Na2CO3 plus H2O plus CO2. Next question. Write an equation to show the reaction between plaster of Paris and water. Plaster of Paris and water. CaSO4 half H2O. If plaster of Paris is CaSO4 half H2O plus 1.5 H2O gives CaSO4 2H2O. Before I remind you that the water molecules cannot be divided as half or 1.5. Actually, two water molecules share two calcium sulfate molecules. Two calcium sulfate molecules share one water molecule. Here also there is not 1.5 H2O. So actually, when two molecules sharing, there is also 1.5 into 3 molecules. But for clear understanding, we are writing on this way only. For the understanding purpose only, understanding a clear idea, getting a clear idea, we have to written as half H2O and 1.5 H2O. Actually, what is happening? This is two molecules share one molecules. two calcium sulfate molecules share one H2. Then each calcium sulfate get half H2. When two share, for when there are only a single suite and there are two students, how we can get it? They divide and each of them get. But dividing is when we want to purchase a suite from the shop, whether the owner of the merchant give you a half suite. Do you understand what I say? Now, two students went to the shop to purchase a suite. When they asked the shopman to give one suite, they also gave them. But one of them went to the shop and asked the shopman, please give me a half suite. The shopman does not give them, it is not their duty to give them half. They say that I can't give a half suite. You two come to and ask me, I will give you one. Then you purchase one suite, pay the price, pay the cash, then they will divide the suite into two. That is here also. What do you understand? They will get two gases in one water molecule, then they share each other. You understand? Then when one is already it becomes CSO or QH2. Then we come to the textbook questions. All the questions are very simple. You can learn the lessons and try to answer by yourself. If there is any doubt, you can ask me to the WhatsApp. First question for a model we can do some questions. A solution turns red, then it must blue. If its pH value is like to be, a solution turns red litmus blue. Red litmus blue. Its pH value is to be 1, 4, 5, 10. The thing, when you are studying about the acid or base, you have to remember in mind is base litmus, base blue. While I am a student also, there is confusion, always confusion about me, how to, in acids what is the color, blue or red, base is what is color. Now in the case of you, there is no confusion. Base blue, the letter base blue. Here the answer is red litmus blue. Blue means there is no confusion, it is the property of a base. It turns base. Then with second thing you have to remember is, if the case is base, its pH is above 7, which is D. As you have seen, learned that bases turn red litmus blue. The basic solution has a pH value of more than 7. Since solution turns red litmus blue, therefore its pH value like to be greater than 7, that is 10. But the answer D. Because a solution reacts with crushed eggshells to give a gas that turns lime water milky. The solution contains a solution that reacts with the crushed eggshells to give a gas that turns lime water milky. When there is any doubt in answering the question, you have to simply write a solution reacts with, a solution means that X react with the eggshell. What is called a solution in X reacts with eggshells to produce PA gas. What's the property gas? It turns lime water milky. Lime water milky. The solution contains what we know? We know that the gas which turns lime water milky, in these two chapters, we have to learn identification of two things only. One, hydrogen, it burns with a warp sound. Then next, carbon dioxide. In these two chapters, we have discussed the two things. How we can identify gas, hydrogen gas. When a lighted matchstick is shown in the front of in the presence of hydrogen, it turns. It burns with a warp sound. Second, carbon dioxide. How we can several times we discuss. How which gas turn light bar milky carbon dioxide gas. So we can conclude which gas is. This is carbon dioxide. Carbon dioxide gas can only turn light bar milky. Then there is also one more thing. What is the milky substance? Calcium carbonate. Then what's the question? Eggshell. What's eggshell? What is eggshell? Calcium carbonate. You know that almost all the shells of the living beings are calcium carbonate. Almost all these things, calcium carbonate. Eggshells, calcium carbonate. That the thing you must remember is eggshell means it is chemically it is calcium carbonate. That is same as that of marble. Chemically marble and eggshell are chemically calcium carbonate. Then this is what. What is the react with the carbonates to produce? Acids react with the carbonates to produce carbon dioxide. Then what is it? Yes. This is the given list is HCl. What's the answer? It is HCl. Next question. 10 ml of solution of sodium nitrate is found to be completely neutralized by 8 ml of a given solution of HCl. Then if we take 20 ml of the same solution of NaOH, the amount of HCl the solution is required to neutralize it will be. Then in this case also you may write the things on a paper. What is given? 10 ml NaOH. 10 ml NaOH is found to be completely neutralized by 8 ml HCl. 10 ml of a sodium solution is completely neutralized by 8 ml HCl. Then what is the question? If 20 ml is taken, 20 ml of NaOH is taken, how many ml of how many HCl is required? We can simply answer it. What's the answer? What's the answer? Simply we can get this 60. How we can calculate it? If a calculation is needed, we can calculate it. How? 10 ml of NaOH neutralizes 8 ml HCl. Then there are 1 ml of 1 ml of NaOH neutralizes 8 by 10. 8 by 10, that is 5 by 4 by 5. Then there is also question 20 ml. 20 ml 20 ml neutralization 20 ml NaOH. Now we can solve it. 4 by 5 into 4 by 5 into 20. That is equal to 60. If any question arises like this, first you, if a written solution is required, first you find out 20 ml, 10 ml required neutralizes 8 ml. Then the second step is, then the 1 ml of NaOH is required, 8 by 10. That is equal to 4 by 8. Then multiply with the required amount. Then the next question, which one of the following types of medicines are used for treating indigestion? Indigestion, which type of medicines? Antacids. Then next question, write word equations and then Barrett's equation for the reaction taking place when dilute sulfuric acid react with zinc granules, dilute hydrochloric acid react with magnesium ribbon, dilute sulfuric acid react with the aluminium powder. You have the previous chapter, you have discussed these things, so you have to look on this and write the answers. Next, compounds such as alcohol and glucose also contain hydrogen but are not categorized as acids. Describe an activity to prove it. I said to you today that what substance that contain hydrogen are not acids. If it took an acid, what is the required quality in moisture? In presence of moisture, it produces hydrogen ions. Acetone, glucose or alcohol, it does not undergo dissociation and not produce hydrogen ions. So it is not acids. In the textbook, we have given that we have learned that there is 2 nails in the core. This is a core. This is 2 nails. When it is placed inside the is connected where based on the changes. What are these here? This is a cord fitted between 2 nails. It is connected to a battery and a bulb. Then fill the solution with the hydrochloric acid. When HCl is taken, it bulb close. Bulb lightens. When H2SO4 is taken, it also, when acetic acid is taken, the bulb close. When we replace the liquid inside by alcohol, the bulb does not glow. The bulb does not glow. That means the circuit is not completing. We don't know that. Please don't look at here. This is the core. This 2 nails. There is no contact between them. If the contact is only between the electrolyte taken into the inside vehicle. So, if there is alcohol is taken, there is no ions. Alcohol is not an electrolyte. It does not conduct electricity, so the bulb does not glow. At the same time, any acid or any base or any salt is taken, all acids or all bases or salts are electrolytes. They conduct electricity. Then the acid is taken, here the circuit is completed and the bulb closed. What does this prove? This is simply experiment you have studied in the lower classes of this prove that alcohol and glucose, though also it contains hydrogen, they are not categorized as acids. That means they does not dissociate to ions. They does not produce hydrogen ions. This proves that we came to the conclusion that all substances that contain acids, that contain hydrogen are not acids. From this activity, we can conclude that all acids contain hydrogen, but not all compounds containing hydrogen are acids. Please be note the point. It can be concluded that all acids contain hydrogen, but not all compounds containing hydrogen are not acids. That is why the compounds like alcohol and glucose contain hydrogen, they are not categorized as acids. Why does distilled water not conduct electricity, whereas rainwater? Distilled water is the pure form of water. The pure form of water is distilled water and it does not contain ions. Therefore, it does not conduct electricity. At the same time, the rainwater, on the other hand, being impure form of water. The rainwater, during rain, there are so many impurities in the atmosphere, dissolve the rainwater and it becomes a good conductor of electricity, an ionic compound, therefore it conducts electricity. Why do acids not show acidic behavior in the absence of water? Yeah, in the absence of water, it does not undergo dissociation and not produce hydrogen ions. So, acids show its property only the presence of hydrogen ions only. These two chapters, if you get time, we can discuss more questions from this chapter. The coming examination, you will have noticed the examination time schedule. It should be conducted the second week of September. There may be separate question paper for each physics, chemistry and biology, not the combined course. So a separate question paper for physics, chemistry and biology. So these we have completed two chapters. These two chapters also include the coming CBSE board exams also. So you must study these two chapters well. And if any doubt, you can directly call me out through WhatsApp and you can clear our doubts. We can get full score in the coming examination. Okay, thank you.